Hi guys, today we're going to have a look at how we can sketch cubic graphs. Now to start off with, we're going to be really kind. We're going to give it to you in this factorized form, and that's going to be really helpful for sketching. Later on you need to learn how to factorize into this form, but it's not too difficult. So with a graph, the first thing we need to know is where it crosses the x-axis, called our roots. So it can be anywhere along here. We need to work out where. Now, if you think about it carefully, it links in with the quadratic graphs. So this point here, anywhere along here, it's when the y-axis is equal to 0. So we put the y coordinates equal to 0, and we can solve it like the quadratics. So you should know that we can split these up. So each of these can be written equal to 0, and therefore we can solve it really easy to be 4, minus 2, and 3. And you probably already know the shortcut. You can just swap the signs. But that's why. If you didn't know why you swap the signs, now you do. Okay, so there we have our x-intercepts, or our roots. Now we've also got to find out with the y-intercept. And normally when we do a graph, we just look at the constant term, the bit with no x. But because it's in its factorized form, we have to be a little bit more sneaky. So, like we did before, you need to realize that all up and down this line is where the x value is 0. Every coordinate up here, the x coordinate is 0. So let's just swap the x's for zeros, and you're going to get this. Times those numbers together, you will get your y-intercept. So this can be achieved by just multiplying these numbers together. And that's why that works. Okay, so 24, it needs to be a lot higher, so let's make it look a little bit realistic. Okay, so you should know what a cubic curve looks like. So it's going to start at the bottom left, it's going to go up to our y-intercept and back through. Now you'll notice that this peak is on this side, on the right hand side of the y-axis, and that's because we have symmetry. Here there's a difference of 5 between the minus 2 and the 3. So it has to be roughly in the middle. Likewise here between the 3 and the 4, it's halfway between them. So like the quadratics, we still have symmetry. Let's have a look at another one. So here we have, again, very similar. So put it equal to 0. When y is 0, we can find out the roots. And now I'm just going to do the shortcut. Just swap the signs. So there they are. Put the x equal to 0, times those together, we'll get the y-intercept of 2. So again, this one's a little bit easier to see the symmetry because it's the same distance either side of the y-axis. So that means at this point 2, it is going to peak there. Just come below and down. As long as you're showing that your line comes below between the 1 and the 2, not flat, and continue a nice smooth curve, that's what we want. Okay, this one. So again, really similar, but you should notice that 2 of these brackets are the same. So let's put it equal to 0 and solve it, and we get 2 exactly the same roots. So it's going to look like that. Now if you think about the quadratics when there would have been just 2, if 2 are the same, it just touched the x-axis. And that, if you use the discriminant, we said that was b squared is equal to 4ac. We said it had 2 roots, because there are 2, but they're 2 equal roots. So the same thing's going to happen. It's going to come up to that point, but just touch it and then come back down. So before we do that, let's find the y-intercept. So just the same as before, and that's minus 3. And this again will tell you that if you go past this, you're going to somehow have difficulty coming back down here. There you go. And last one, this one's the trickiest of them all. So let's put it equal to 0, and we can find the root values. But I want to just draw your attention to this middle bracket, because 0 equals 1 minus x. My advice is to remove the minus x to the other side. So that's how we get the 1. So there they are. Let's put it equal to 0, and we get 2. So you should notice, if I was trying to come from below, I'd go through the -2, I'd then come back down to go through the -1, and then I wouldn't be able to get back up here. So straight away you should think, well, this one's either wrong or I'm missing something. And it's because you've missed something. If you look at these x values at the top here, x times negative x is negative x squared, times another x is negative x cubed. So this means it's a negative x cubed graph, which means we're reflecting it in the x-axis. So instead of starting in the bottom left, we're actually starting in the top left. So we're going to come down, up through the y-intercept, and then back down. And that is how you sketch a cubic graph.